Good day, grade 10s. So today we're going to learn about Euclidean Geometry Lesson 2, where we're going to focus on triangles. Now, I have a beautiful picture with me here. The picture is about the pyramids of Giza. I put this picture on purpose because the lesson is going to be about triangles. So I want you to see the amazing geometry of triangles. As you can see, the pyramids of Giza, they have triangular shapes on their faces, right? Yeah. So these pyramids, they are a historical and a tourism site in Egypt. Yeah. And so let's start our lesson on classification of triangles. So the first classification, we have the definition of a scalene triangle. A scalene triangle is a triangle that has all sides and angles that are different. A triangle where all sides and angles are different, it's called a scalene. For example, we can have a triangle of this form, where we have 7 centimeter this side, and then we have 6 centimeter, for example, and then we have 5 centimeter. So we have 3 different sides, and the angles also, they have to be different. So in a scalene, the sides and the angles are different. And then we can have a situation where the angles are different. A situation where the angles are different, we can have 80 degrees. We can have 60 degrees, and then we can have 40 degrees. So we have different angles and different sides. So this is a scalene triangle, right? So that's a scalene triangle. And then the second one is an isosceles triangle. An isosceles triangle, it's a triangle where 2 sides are equal in length and the angle opposite the equal sides are equal. So this is an isosceles triangle. So you'll have a triangle like this, and then this side and this side are equal. And then if we have A, B, C, right, it means the angles at the base, this side is opposite this angle, right? So this side is facing this angle, and this side is facing this angle. Because of the 2 sides that are facing these angles are equal, it means their angles are also equal. So angle B is equals to angle C. This is what this statement says. The angles opposite the equal sides are also equal. So that's what it tells us. So B equals to C. So A, B is equals to AC, and angle B is equals to angle C. And then the definition of equilateral triangle. An equilateral triangle is a triangle where all 3 sides and angles are equal, right? So that type of a triangle can have an equilateral triangle where all the 3 sides are equal. We have A, B, and C. And then because all the 3 sides are equal, all the angles are also what? They are also equal. And then the angles here, they are all what? 60 degrees. So all the angles and the sides, they are equal, right? And then we know that x plus x plus x is equals to 180 sum of angles in a triangle. You learned this in earlier grade 8 and 9, about that when we add three angles in a triangle, we get 180, right? And then if we add the 3, we get 3x bar is 180, and then we divide both sides by 3, and then angle x is equals to 180 divided by 3 will give us 60 degrees. So you see, it means an equilateral triangle, all the angles inside it, they are what? They are 60 degrees. And then the definition of an acute angle. An acute angle triangle, the definition of an acute angle triangle is that it's a triangle where each of the three interior angles are less than 90. So an acute triangle is a triangle where the interior angles are less than 90. So let's draw. So we have this triangle here. So the angle here, let's say we can have 50 degrees, we can have 70 degrees here, and then we can have we have what, 60, we can have 60 here. So 70 degrees, 50 degrees, and 60 degrees are all less than 90 degrees. So it means we have ABC. Therefore triangle ABC is an acute angled triangle. So that's an acute angle triangle. All the interior angles must be less than 90. And then an obtuse angled triangle, it's a triangle where one interior angle is greater than 90. So in this situation, we can have this triangle A, B, C. And then in this triangle, we can, for example, have an angle here that is 130. We don't need to know other angles. The moment we have an angle that is 130, then we know, because of 130 is greater than 90. Therefore, triangle ABC is an obtuse angled triangle. And then the definition of a right angled triangle is that it's a triangle where one interior angle is 90 degrees. So a right angled triangle is a triangle where one interior angle is 90 degrees. In this case, angle B is 90 degrees. Therefore, triangle ABC is a right angle. It's a right angled triangle. And then now we have a theorem. A theorem is sort of a principle. A theorem, the theorem of interior angles of a triangle, right? So the theorem says that the sum of angles in a triangle add up to 180. So we have a triangle here, right? And then we have A, we have B, and then we have C. So the sum of angles in a triangle, they add up to 108, right? So we are gonna prove that. So I'm gonna do a construction. I'm gonna construct the line here such that the line, so here I have A, B, C, and I'm gonna construct CD. So we construct CD, right? After constructing CD, so we construct CD such that CD is parallel to AB. So then we have this situation here, right? And then we're gonna extend C. We're gonna extend AC into E. So we'll have this. Right? After doing this, now, do you see what I see? I see a Z here. Then here I see a Z. And what did we say about a Z? Alternate angles. And the alternate angles, they do what? They are equal when the lines are parallel. So after doing that, do we see that angle? We can see that B, this angle here, right, is the same as angle A. In other words, B, angle BCD is equals to A, right? Yeah, so angle BCD is equals to A. And we also see something. I see, okay, the reason why this angle is alternate angles because of AB is parallel to CD. And then another thing that we see here is the F shape. This is the F shape that I'm seeing. And the lines are parallel. So this angle here and this angle here, they're equal. It means here it's B. So basically gonna say angle DCE is equals to B. These are corresponding angles because of what? AB is parallel to CD, right? Then after that, we now have these angles. We have angle C plus A plus B. When we add all of them, we get what? 108. Reason, angles on a straight line. Now, if we write them in order, we're gonna have what? Angle A plus angle B plus angle C is equals to 180. But what is angle A, angle B, and angle C? These are the angles. This is A, this is B, and this is C. These are the three angles inside the triangle. So then we have proved that sum of angles in triangle equals to 180 degrees. Very interesting, right? And then the next theorem says the exterior angle of a triangle. The exterior angle of a triangle is equal to the sum of the interior opposite angles. Then let's draw the triangle. So we have a triangle that has an exterior angle. Let me rub this off so that I can make it smaller a little bit. So we have this triangle here that has an exterior angle, an angle that is outside, and then we have A, B, we have C, we have D here, right? And then I have the internal, the angles that are inside here. Let's say we have A here, small letter B, and small letter C here, right? And we also have small letter D here. So we want to prove what? We want to prove that angle D is equals to A plus B, right? So how do we prove this? How can we prove this? How can we show that D is equals to A plus B? This is very, very interesting. So we're gonna do construction again. So I'm gonna extend this line here, which I will call E, right? And then it's parallel. So we construct CE such that AB is parallel to CE. And then after doing construction, we're gonna observe that we have what? We have a Z shape here. And then it means this angle and this angle are what? Equal. So the angle here is A. And then after that, we will also observe that we have an F shape here. Means this angle and this angle are the same, it's B. But the whole angle here is D, right? So it means what? It means D is equals to A plus B. Then this is the proof. So we just proved that the exterior angle of a triangle is equal to the sum interior opposite angles. So D here is the exterior angle. Yeah. And then next we have congruency. Yeah. Now we have congruency. When we talk about congruency, we are referring to equality in terms of sides and angles, since here we are referring to triangles, right? Yeah, so that's what we talk about. And then the first part of the congruency has conditions, right? Yeah, congruency has conditions. So the first condition of congruency is RHS. So first condition is RHS. This happens when we have two triangles that are right angle. We have triangle ABC and triangle DEF, and these triangles, they have the same hypotenuse and they also have the same value of the other side, and they have a 90 degrees. So this is RHS. R stands for right angle and H stands for hypotenuse, which is this side. They both have the hypotenuse and they are equal. and then S stands for the side, and they all have the side that is corresponding, which is equal also. Therefore, according to this condition, we can say therefore triangle ABC is congruent to triangle DEF. So that's the first condition. The second condition, says SSS. It stands for side, side, side. This is a situation where we have two triangles, triangle A, triangle Q, P, R, where we have this side, and then we have another triangle S, T, U, and then we have this side equals to this side and their corresponding sides, and then you have this side equals to that side and their corresponding sides. So because the corresponding sides are equal in length in these two triangles, right? For example, this side is equals to this side, and this side is equals to this side, and then this side is equals to this side. Therefore, we make a conclusion that therefore triangle PQR is congruent to triangle STU. Congruent means they are equal in everything. That's what congruent means. And then the next condition, it will be the third condition. The third condition states that it's side angle side, but the angle here is an included angle. So meaning this is a situation where we have two triangles, and then we have triangle FGH, for example, and triangle IJK, and then we have corresponding sides equal. This side is equal to that side, and then we have the included angle, which is this angle here. This included angle, it means it's basically an angle. For example, in this triangle, the two sides that are equal, the two sides that correspond to the sides in the other triangle, right? They form an angle. So if this happens in the other triangle, then those triangles will be congruent, because this, for example, if you look at this side is equal to this side, and then this side is equal to this side, and both of them, they form this angle, the green angle. And because they form the green angle, both of them, and they are equal and they correspond, so they form an included angle in both triangles, then those triangles will be congruent according to condition number 3, right? And then we have the fourth condition. Then the fourth condition, so before we do the fourth condition, let me write the fourth condition here. Then here, triangle FGH is congruent to triangle IJK. And then the fourth condition says what? The fourth condition is angle angle side. So the fourth condition is angle side. It basically means that if one side and two angles of a triangle are equal to the corresponding one side and two angles of another triangle, then the two triangles will be congruent. So if we draw them right here, we'll have two triangles again. Then we have this triangle, and then this is triangle U V W, and this is triangle X Y Z, right? Then I have this angle corresponding with this angle, and this angle corresponding with this angle, and then I have this side corresponding with this side. So in this situation, because we have this side equals to that side and they are corresponding, they must not only be equal, they must also correspond. Is very important. Correspond means that they must be at the same position, and the angles must also correspond relative to those sides in both triangles. Very important. And then we have the angles. We have this angle here is equals to this angle, and then we have this angle here is equals to this angle. So according to this condition, if these three are met, then we can conclude that triangle UVW is congruent to triangle XYZ. So that's how we will basically make a conclusion on the congruency part, right? And then if you check here, we have to also talk about the Pythagoras theorem. So to talk about the Pythagoras theorem, I'm going to clear this part. The Pythagoras theorem. So the Pythagoras theorem says what? Pythagoras theorem says in a right angle triangle, we have a right angle triangle, and then we have side A, B, and then you have C. And then C is the hypotenuse. So the Pythagoras theorem says what? So the Pythagoras theorem basically says that a squared plus b squared is equals to c squared. And then if, let's say, there were letters P here, and then we have Q, we have R, then using the big letters, then the theorem will be what? It will be PQ squared plus QR squared is equals to PR squared. So the hypotenuse is always on this part. Yeah, so this is how the Pythagoras theorem is like. So this here is the Pythagoras theorem. And then now we have example 1. And then example 1 says determine if the two triangles are congruent. So then here we want to determine whether the two triangles are congruent or not, right? So in order to do that, what must we do? So we're gonna check. So we have 3 here and then we have 3 here, but it doesn't tell us anything. We don't have enough information, so we have to fill in other information so that we can have enough information, right? So what is what is angle? What is this angle here? We can find it, right? So we can add all the angles in this triangle and then we find that angle. So then we're gonna say in triangle CDE, right? And then we say angle E plus 35 degrees plus 90 degrees is equals to 180. Reason, sum of angles in a triangle. The sum of angles in a triangle equals to 180, right? And then we have angle E plus 35 plus 90 is 125 equals to 180. And then angle E is equals to 180 minus 125. Therefore, angle E is equals to, and then 180 minus 125. 180 minus 125 should be 55. So that's 55. So we have 55 degrees here, which corresponds to that one. So we are getting close to basically proving that the two triangles are congruent, right? Yeah. So now we have information. Now let's check if we can conclude that the two triangles are congruent, right? So we have, what do we have? We have this side. We have side AB is equals to side DE, right? Yes. Yeah. So side AB is equals to side DE. And we know that this is basically given, obviously, right? Yeah, so it's given. So we can say DE AB is equals to DE. Both of them, they are 3, so it's given. And then the next thing that we see is what? It is the angles. The next thing that we see is the angles. We see that we have an angle of 55 here, and we also have another angle of 55 here, right? And then we see something strange, right? This angle is close to this side, and on the is close to the side with length 3, and the same thing happens this side, right? So we can write that angle and say angle B, angle CAB, angle CAB or angle BAC. So angle, already there's angle CAB. Angle CAB is equals to angle CED. then both of them, they are what? They are 55 degrees. We just showed that, right? Yeah, this one is proved. We showed. And then the next one is what? The next one is the 90-degree angle. So if I check here, we have this angle that is 90 degrees. So then we're gonna say angle ABC is equals to angle CDE. So both of them are 90. Then this one is given. So then in this situation, we now have side, and then we have angle, and then we have angle. Therefore, we can conclude that triangle ABC is congruent to triangle CDE, and reason will be angle, side. And then now we can use this statement to find the value of x, y, and z. So from this statement, we can find the value of x, y, and z. So what is the value of y? So the value of y is going to be easy to find now, right? You can just find the value of y easily. Yeah. So now then we have the value of y. So finding the value of y, we're going to say in triangle ABC, then we say y plus 55 plus 90 is equals to 180. Then this is sum of angles, right? Yeah. Or because the question said we must use the result, what we can also do, we don't have to use this. We can just use the result. We just proved that the two triangles are congruent, right? Yeah. So in this case, we can just make a conclusion. So y, the value of y so the value of y is equals to what? It's equals to 55. No, it's equals to 35. The reason why it's 35 is because of what? Triangle ABC is congruent to triangle CDE, because the question said that we must use the result to find x and y. So y is 35. We don't need to use long steps. And then the value of x will be what? Then the value of x, we just look for the side that is opposite, and then we'll be able to find the value of x. So we're gonna start with the triangle that has enough information. So the triangle with enough information is triangle CDE. So then we say in triangle CDE, we're gonna use Pythagoras. And then the longest side, the side facing the 90-degree angle, this is the hypotenuse. So this side is the hypotenuse. So then we're gonna say CE squared is equals to DC squared plus DE squared, right? CE squared is 5 squared, and then DC squared is x squared, and then DE squared is 3 squared. 5 squared is 25, and then x squared is what we are looking for, and then 3 squared is 9, and then 25 minus 9 is equals to x squared, and then 25 minus 9 is 16, and then we do the square root both sides, then we have x, and therefore x is equals to 4. It means here we have 4, and then because we have 4 there, then now we can find the missing values, z, the value of z. So what is the value of z? We can see that the value z is the hypotenuse. Therefore, we can say that z is equals to 5. Reason: triangle ABC is congruent to triangle DCE. Because when triangles are congruent, it means everything about them is equal. So yeah, don't forget that. And then we get into similarity. And then into similarity, when we talk about similarity, we refer to shapes that have the same shape, but they are different in size. So in terms of triangles, we can have 2 triangles here, and then we have I have a bigger triangle here, and then I have triangle ABC, and then triangle DEF, and then I have angle small letter A, small letter B, small letter C, and I have angle A, angle B, angle C. So if you check, you see here both triangles, they have the same angle. So the first condition 1, is that if angle A is equals to angle D, and angle B equals to angle E, and angle C equals to angle F, therefore triangle ABC is similar to triangle DEF. Yeah, so this symbol here means similar. And then the condition here is that it's gonna be angle, 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 right? And then condition 2, it means is when we have 2 triangles, M, N, L, then I have another small triangle here, which is R, S, T, right? Then this condition says that if Mn over Rs is equals to Ml over Rt and is equals to Nl over St, therefore triangle MNL is gonna be similar to triangle RST. So here it talks about the sides in proportion, and this we write it as S, right? So these are the two conditions of similarity. So what does this mean? This means that, for example, if I have if for example I have 5 centimeter, and I have 4 centimeter, and I have 3 centimeter, right? And then this side I have 10 centimeter, and I have 8 centimeter, and here I have 6 centimeter. If you divide those, if you say mn over rs, you're gonna get what? Mn is how much? Is 5, right? 5 over rs. No, mn is 3, sorry. Mn is 3 and rs is 6. 3 over 6 is 1 over 2. And then if you do the same thing, you find ml over rt. ml over rt. ml is how much? It's 5 and rt is 10. 5 over 10 is what? Is 1 over 2. And you do the same thing with nl. nl over st. nl is how much? nl is 4 and st is 8. 4 over 8 is what? Is 1 over 2. So what do you notice? We get the same ratio. Because we get the same ratio, it means what? The sides are in proportion, so the two triangles are similar. So that's what this part is telling us. And then now we can do some few problems together. So number one, we want to calculate the unknown variables. So here we are dealing with an isosceles triangle. How do we know that this is an isosceles triangle? Because the two sides are equal. So this is an isosceles angle because NO is equals to PO. Therefore, it means what? Angle N is equals to angle P, right? So that means X is equals to Y. So therefore, we can now start. We can say X plus Y plus 36 is equals to 180. Reason: sum of angles in a triangle. But X and Y, they are equal, so we can replace Y by X. So you have 36 equals to 180, and then X plus X is 2X plus 36 equals to 180, and then 2X minus 180 minus 36, and then we have 180 minus 36 is 144. Divide both sides by 2, get X is equals to 72. And because X and Y are the same, that means Y is equals to 72 also. So that's how we find X and Y. And then the second problem, calculate the unknown variable. We want the value of X. Then here we're gonna use the exterior angle of a triangle. So the value of X is an exterior angle. So the exterior angle of a triangle is that the exterior angle is equals to what? This angle plus this angle, angle N plus angle P. And then we have angle N is 30, angle P is 68, and the exterior angle is X. Therefore, we have X is equals to 30 plus 68 is 98 degrees. The next problem, calculate the unknown variables. Then we want to find the value of y first. Then to find the value of y, you can just say angle y and 68, they are lying on a straight line. So we can just say y plus 68 equals to 180. Reason, angles on straight line. And then y is equals to 180 minus 68. Therefore, y is equals to 180 minus 68 gives us 112 degrees. And then it means we have 112 degrees here. (112 degrees). This angle here is 112 degrees. And then now we want to find angle X. So we can find angle X using the fact that this angle here is an exterior angle. So we're gonna say exterior angle is equals to N plus P. So this is our N and P. And then the exterior angle is 112. And then angle N and angle P is X, right? And then we say 112 minus 68 is equals to X. And then 112 minus 68 gives us 44. So therefore the value of X will be 44. The next problem, calculate the unknown variables in this shape. Then in this shape, you can see the two triangles are not equal in size, right? So here we are gonna use similarity. So this is a similarity problem. So we want to find the value of X. So in order to do that, we have to first prove that the two triangles are similar, right? So we can do that. So we see that angle N is equals to angle R. They are both 90, right? And then we can also see that this angle and this angle here, they are equal. So that's angle NOP is equals to angle ROS. These are vertically opposite angles, right? And because of two angles are equal, the third angle will be equal. So then this is how we write it. We write and say then angle P is equals to angle S. Reason, the third angle. Therefore we make a conclusion. Therefore triangle NPO is similar to triangle ROS. Reason, angle, angle, angle. So the triangles are similar. And because the triangles are similar, it means what? The sides are in proportion. So similar triangles have sides are in proportion. Or same ratio. So what does this mean? It means we're gonna divide the corresponding sides, right? This side, then this side goes with this side. So then we're gonna say SO over PO is equals to, and then this side facing this angle is gonna go with this side facing this angle. So it means we're gonna say what? Because the top sides, the top side comes from the bigger triangle, so it means we're gonna say RS over NP. And then next we have this angle we just showed is equals to this angle, right? So this side is facing that side and this angle is facing this side, so it means it's gonna be RO over NO. And now we have the information we need to find the value of X. So we can put in, what is the value of SO? SO, we don't have it. What is the value of PO? We don't have it. So we're gonna say SO over PO is equals to, what is the value of RS? Is 76. What is the value of NP? Is 19. What is the value of RO? Is 116. What is the value of NO? Is X. And then we're gonna choose this information. And then now we can solve for X. And then when we solve for X, we do cross multiply. Then we're gonna have 76x is equals to 116 times 19. 76x is equals to 116 times 19 is how much? It gives us 2204, and divide by 76. The value of X becomes, divided by 76, it becomes 29. So this is our X value. Next one, here we're gonna use the Pythagoras theorem. So here we use the Pythagoras theorem to find X. So the longest side is the side facing the 90 degrees. So this is the hypotenuse. So then you're gonna say the longest side squared, which is NO squared, is equal to NP squared plus PO squared. NO squared is X squared, and then NP squared is gonna be 15 squared, and then PO squared is gonna be 20 squared. Then X squared is equals to 15 squared is 225. 20 squared should be 400. And then 400 plus 225 gives us 625. And then we square root both sides. The square root of 625 should be 25. And then this is the value of x using the Pythagoras theorem. And then the next problem, we want to find the value of x and y. The two triangles, they are not the same in terms of shape, no, in terms of size. So we are basically going to prove that they are similar, right? So here, what are we going to do to show that the triangles are similar? So we're gonna first say to show that the triangles are similar, we're gonna first say what? We first have to use the Pythagoras theorem to find the value of x. Why do we find the value of x using Pythagoras theorem? Because we have enough information in triangle NRO. So in this triangle, we have enough information to find the value of x. So we use the Pythagoras theorem. Then using the Pythagoras theorem, we're gonna have the side facing 90 degrees is this side. So it's gonna be NR squared is equals to NO squared plus RO squared. What is NR squared? Is 15 squared. NO is x squared, and RO squared is 9 squared. 15 squared is 225, and then we have x squared. 9 squared is 81. 225 minus 81 is equals to x squared. And then 225 minus 81 is 144. And then square root both sides. The square root of 144 is 12. So we know x is 12. And then now we can find the value of y. So we have this triangle. Now we have enough information. The value of x is 12. So then we can, the side facing the 90 degrees in this triangle is this side. So that means we start with it. So we say PO squared is equals to NP squared plus NO squared. PO squared is going to be y squared. NP squared is going to be 5 squared. And NO squared is going to be x squared. But the value of x, we got it is 12, right? So then we're going to have y squared is equals to 5 squared plus x squared is 12, so we have 12 squared. And then we have y squared is equals to 25 plus 144. Then 144 plus 25 is 169. Square root both sides. The square root of 169 is 13. So the value of y is going to be 13. And then in this problem, number 7, it says, state whether the following pairs of triangles are congruent or not. Give reasons for your answers. If there is not enough information to make a decision, explain why. So if there is not enough information to make a decision, we're going to explain why, right? So then now if you check in this triangle, we have this angle here is equals to this angle, right? They are vertically opposite angles. So BCA is equals to ECA. They are vertically opposite angles. And then what do we have? We have AC is equals to EC. It's given. And there are also corresponding sides. It's very important. And we also have BC is equals to CD. It's also given. And there are also corresponding sides. Therefore, we can make a is congruent to CDE. And then the reason will be single side. And then we have number B. Number B, what do we have? We have angle A is equals to angle D is given. Is this angle here and this angle here, they are equal. It's given that they are equal. And then we have AB is equals to BD is also given. And then we also have BC is equals to BC is common side. Therefore, we can conclude that triangle ACB is congruent to triangle BCD, reason side angle side. But we have to be careful in this triangle. Let me wrap this because I see I see some misconception that can arise. This is one of the most difficult problems, especially here in grade 10. This triangle has a lot of misconception that is associated with it. Now let's start and analyze this triangle correctly. Okay, what do we have? We have what is given. We are given that angle A is equals to angle D, right? This is given. No problem. And the other thing that is given is what? That angle AB is equals to angle BD is also given, right? And then the other thing that is given is that BC is equals to BC. This is a common side. But when you look at this, it looks like what? Side angle side, right? But we really can't conclude that triangle ABC is congruent to triangle BCD. Why? Because I can shift this line here because we don't have enough information basically. That's the reason. we don't have enough information. The information that we don't have is that it looks like they are congruent, right? But in reality, we can't really conclude that they are congruent. So if you look at the triangles, we have two equal sides, which is AB equals to BD, this part, right? And then we have BC is a common side to both the triangles, right? And we have one angle, angle A equals to angle D, right? But the sides do not include the known angle. Yeah, so the sides do not include the known angle. So since the sides, they do not include a known angle, and the sides that we are referring to here, it's basically side AB and side BD and side AC and side CD, right? Because they don't include a known angle, they can lead to misconception. The misconception that can arise that we are referring to here, for example, the angle that is here and the angle that is here, they are not necessarily 90-degree angles. So because of the angles here are not so we can't really say that they are equal, right? So therefore it means that the two triangles are not congruent. So basically here we don't have enough information to really make a conclusion, but yeah, that's the analysis. We don't have enough information. If the angles here were 90 degrees, then we can make a conclusion that the triangles are congruent, right? So yeah, so that's the analysis of this problem. So you need to be careful when you deal with these problems, because they can be very, 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 very complicated. Can be very, very, very complicated, right? Yeah, because you can have a situation like this where you have a triangle and then you have this, right? Then you have B, A, D the same way, and then you have this side equals to this side, and then you have this angle is equals to this angle. But then you are told that the angle that is here, for example, is 80. The angle that is here, it's, for example, 80 degrees, and the one that is here is 100 degrees. So do you see the problem? This is where the problem arises. So the two triangles, they are definitely going to not be congruent, you see? So don't be misled by this line. It can mislead you. It looks like the triangles are congruent, but they are not actually congruent. Yeah. And then C, let's see if we have enough information to determine whether the triangles are congruent. So we are given that BC is equals to EC. This one is given. And then we have AC is equals to CD is also given. So in this case, because of the lines do not cross one another, the lines do not cross one another, right? For vertically opposite angles, they only happen when you have this situation. This is vertically opposite angles, when two lines cross each other. But here we don't have that situation, so this angle and this angle are not so therefore we don't have enough information. So in this case we don't have enough info. And then the next one, the next one, then we have this. This is vertically opposite. These ones are vertically opposite. These ones are vertically opposite, so we can say BCA is equals to ECD. They are vertically opposite angles. Yeah, then we are also what information do we have here? Do you see a problem here? We don't have enough information again. We don't have any information about the sides of this triangle related to that triangle. So we can't make a conclusion basically. So because we don't have enough information about the relationship between the sides of this triangle and the sides of that triangle, then we can't conclude whether they are congruent or similar. We can't. Yeah, so what we know is that both triangles are isosceles. But we don't have enough info about the sides of both triangles in relation to one another. And then we have the last problem. So here we have the shape of a kite. So here we are given that B is equals to D, right? This is given. And then we have angle DAC is equals to angle BAC is also given. So this angle here is equals to this angle. So do you see that here we have enough information, and then we have a common. AC is equals to AC is common. We have a common side. Therefore, here we can make a conclusion. Therefore, since we have a common side and then we have enough information about the angles, right? Therefore, we can say triangle ABC is congruent to triangle ABC. Reason will be what? It will be side angle, angle. And then this is how we do the problem. And yeah, so we'll meet next time when we do quadrilaterals.